Hi there, this is video 531. We're still working with Z-scores, and there's a couple of questions. One of them is quality control, and the other one is warranty, that are really common questions that they're a little weird to start off with, but I'm going to step you through this one, and you'll see it's really not that bad. All right, so here's the deal. The ABC company makes bungee cords. When the process is running well, the lengths of the bungee cord are produced are normally distributed. Okay, well, obviously I copied these out of a book because I keep forgetting to say that. But so we got a normal distribution with a mean of 45.2 and a standard deviation of 1.3. Okay, you know what? The truth is, the moment you see that, the moment I see that, I'm done reading. I'm going to draw myself a curve because I can't think of any question where I didn't need the curve, if only to check it at the end to see if my answers are reasonable. All right, put it over here. Okay, so we got frequency. And there's our mean. Centimeters. Okay, so there's our mean, there's our mu, and there's our standard deviation of 1.3. So you don't have to do the plus and minus 1.3s. That's up to you. It makes me happier because then if somebody's a little confused about where stuff came from, it's there. And truth is, I just don't like making mistakes in front of you, even if it's on video. So I'd rather just do it right. 5.2 plus 1.3, 46.5, 47.8, 49.1, and if we go the other way, 45.2, minus 1.3, 33.9, okay. Oh, might as well put our percents in before we go any further. 0.15, 2.35, 13.5, 34, 34, 15.5, 2.35, 0.15. Okay. Now it says bungee cords shorter than 42 or longer than 48 are rejected. Now, when I see the 42, I look down here and go, excuse me, gosh darn it, 42 is not on my list. It's not one of my magic numbers, so I know right away I'm going to do a Z-score. So I'm just going to eyeball, and I'm going to say that 42 is right about there. I don't know. It doesn't really matter where you put the line, as long as it's somewhere between 41.3 and 42.6. And I'm thinking 48, yeah, that's not going to be on my list either. All right, I'm going to say that that one is right there. So what's going to happen is they're going to reject the ones out here and the ones up here. So it's not going to be very much at all. But I can't get a good number because these are not on my nice little standard deviation numbers. So I'm going to have to do my Z-scores. Here's my co-host. Say hi, Jelly Bean. Jelly Bean. There you go. Good girl. All right, back to work. All right, so we need to do a Z-score. All right, and we're back. My husband just took Jelly Beans for a walk because she decided that the moment I started making videos, she has to be the co-star and really just wanted my attention. Not too different from children occasionally, I bet. All right, back to the question. So the moment I saw mean and standard deviation, I knew I wanted to draw a curve. Okay. And then I checked the numbers that they were talking about, that the question's about, and they are not one of my standard deviation numbers across the bottom. So I knew I had to do Z-scores. And I just sketched them in so that when I do my Z-score, I can see that it's reasonable. And it also gives me an idea because according to this, they're going to reject the ones that are shorter than 42. So it's this area in here. And the ones that are longer than 48, which is up here. So it's not going to be very much. I don't know how much. I don't know. Wild guess, like 1% maybe ish. I don't know. It's hard to tell because these, well, you already know, right? These things aren't square, so it's not like I can guess, well, this will be half of that or something. That's what the Z-score is for. So Z-score is equal to X minus X bar, oopsies, over sigma. I'm going to do this just because. So so 42 is the number the question is about, minus X bar, which is my mean. So 45.2 over my sigma. All right, that's a sigma. That's just the way I make them. It's my standard deviation of 1.3. So Z 42 minus 45.2 equals minus 3.2 over 1.5. Oh, okay, 1.3. Whoops. Sorry, I got a little worried there. So 3.2 divided by 1.3. There. Now, remember with your Z-scores, you always round to 2 decimal places because we're going to have to read it off that table right away. Before I go further, I want to see if my answer is correct. So first of all, the negative, right, I'm looking at this one, says I should be below my mean, which I am, and it says 2.46. So this is 1 standard deviation, so that'd be minus 1. That's minus 2 there. Yep, that seems quite reasonable. All right, I think what I'm going to do is I'm going to calculate out 48 first, and then I will grab our table, the Z-score table, and convert those into percentages. So Z is equal to X minus X bar over, ooh, that one's better. So this time it's 48. And everything else is the same. So my mean is still 45.2. And my standard deviation is 1.3. Divided by 1.3 is 2.15. And didn't do that on the other one, but I'm going to throw SD for reminding myself those are standard deviations. And before I go further, I want to check. So here's my line. There's plus 1 standard deviation. There's plus 2 standard deviations and a little bit more. So that's one of the reasons I like drawing the curve, is so I know, yeah, when I did my Z-scores, they're reasonable. the most common mistake people screw up is they'll mess the sign, usually on the negative side. So watch for that, and your diagrams can help you. All right, now comes the fun part. I'm just going to write these on as minus 2.46, where you get the z-score table. Now, I'm hoping by the time we get to this chapter, you will have textbook, you will have an online version, or at least you're going to have a paper copy of the z-score table. There's one in the back of the textbook, and I've got one here in a workbook. So I'm going to look up 2.46. So remember, because the odds are pretty slim that I'm going to remember what I read here to be able to write it on my other sheet. So I'm just going to write here. So this much of my number is in the vertical column here, is in this column. And then the sixth part is going across the top. So I need negative 2.4. And don't get weirded out. On this side, it starts at negative 2.9 and it gets closer and closer to 0. So there's my 2.4 line. The nice part, what you guys can do if you want, is you can use your highlighters if you're not using the textbook, right? If you have just a written out or a photocopy of it, it's easier to use. I don't want to do that. Now, there's my 2.4 and there's my 6. So I just read down 0. Oops, where is it? 0.0069. I want to double check. There's my negative 2.4. There's my 6.0069. Okay, so there's the 1. Now I needed to go 2.15. Now I have to be careful because this was a negative 1. This is positive. So it's on the other half of the chart. Sorry. My ruler. Okay, so on this side, whoops. It looks all bendy. 2.15. So this one starts at 0 and gets bigger. So I'm going to go down here to the bottom, 2.1. And then I need to read across. Oh, you can't see me doing that. 2.1, and then I read across with 5. So 2.1, and there's a 5, so 98.42. Cool. I'm just going to transfer this. So I just go A, and the A stands for the area under the graph. So the percent, 0.0069. Now that's as a decimal. So you always go times 100. So it's 2 decimal places. So A is equal to 0.69%. And that makes sense. Oh, yeah, you can see it for this corner, because this last chunk here is 0.15. And then we've got part of this one, but not very much of it. So we're good. Now, this one was 0.9842. And we're going to multiply, so A equals, we'll multiply through by 100. So A is equal to 98.42%. And we said it was this little area here. Yeah, I'm thinking you're all clever enough to realize that this part over here that I colored is not 98% of the graph. We did not screw up. I bring my table back. Ugh. Sorry guys, I'm sure there's a easier way to do this, but right now this works for me. It's my summer holidays. I'm doing the best I can right now. That's why there's this little bitty picture that always shows up there. It says, it always does a z-score equal to or less than a specific data. So it's always giving you the area to the left. So what does this 98.42% refer to? It is not this little chunk at the end. It's everything that isn't yellow. Oh, if only there was some way we could figure out how much that was. Yeah, okay. So basically, the table always gives you the stuff on the left-hand side. So this part is 98. So if we go 100 minus 98.42, oh goodness, I don't know what I just did there. Let's try that again. 100 minus 98.42, 1.58. So that means this chunk here is 1.58%, and this chunk, my green pen, over here is 0.69%. What did they actually ask us? Well, here's my question, right? Didn't even get to the question yet. So bungee cord shorter than 42, so 0.69% are rejected because they are too short, and 1.58% are rejected because they're too long. They want to know if 20,000 cords are manufactured each day, how many would you expect quality control to reject? So let's do this. Total rejected would be 0.69 plus 1.58. I don't know what my calculator is doing. 1.58 plus 0.69. Let's just start over. 2.27. All right, so 2%, 2.27% of their cords are rejected. So if we multiply that by 100 to, hold on, that's not right. We want to divide it by 100. So percent over 100, just do it right. I haven't done a video in about 6 days, so I'm out of practice. Times the number that we have, like we've been doing all along. All right, so 2.27 divided by 100. So that converts it into a decimal times 20,000. So 454 cords are rejected every day. Now, I'm not sure how much each one of those cords is worth, but that's, to me, that seems like an awful lot. So, wonder how they could fix that. Maybe they need to make some adjustments to the machines so that their standard deviation was smaller and they wouldn't reject as many. Or maybe they need to, widen their standards out a little bit more. Because it's, 0.69 down here, it's 1.5 out here. So maybe if they change that to like 49 centimeters, extra centimeter there, it would reduce that down to just a little over 0.15%. But I don't work for a company. I'm not looking at the bottom line. I am doing a math question, and ta-da, there we go. There is our answer. 454 cords are expected to be rejected by quality control every day. Thanks, and have an awesome day.